All right, so let's finish these last two problems of 7.4 and dive into 7.5. So up next, what we need to do is solve for the indicated variable. And so they want us to solve this equation for t. And a similar idea is going to happen. The first thing we want to do is get rid of denominators. So what we're going to do is we're going to multiply both sides by t plus 5 over 1. When I do that on the left-hand side, I'll get just simply t plus 5 times v. On the other side, because I'm multiplying by t plus 5 in the numerator and there's a t plus 5 in the denominator, they will cancel out and I will just get 50t. Now that feels kind of weird because we had t on, the same side of the equal sign, but we just want one t. Right now it's solved for v. There's only one v and there's all this other stuff, but it's just v equals and we're done. So it seems like, why would I multiply this t plus 5 into the numerator in order to solve? And I guess maybe you'll see why, but it just feels counterintuitive, but just know that it's never easy to solve for a variable if that variable is in the denominator. So we're always going to multiply that through to both sides. And I mean, that's the same thing we did all in this solving section, just to kind of make that clear. Okay, so the thing is now that this t is living inside of a parentheses, and we kind of want to free it from a parentheses, so let's actually distribute what we have here. So we have tv plus 5v equals 50t. And now I am going to start solving for t. And here's the way I'm going to do that. I'm going to subtract 50t to this side, and I'm going to subtract 5v to the other side. What I'm doing when I do that, when I subtract 50t to the left-hand side and I subtract 5v to the right-hand side, really I'm subtracting 15t from both sides and subtracting 5v from both sides, but it effectively moves it to the other side. Anyways, what that then does for me is it puts all the t's all in the numerator and all on one side of the equal sign. And so the idea is t is multiplying to v, and t is multiplying to negative 50, so why not distribute it out? And when I do that, that now means that, hey, I just have t times all this stuff, and if I want to get t by itself, I just have to divide all that stuff. And there we go. All right, the next one also isn't too bad. It's really just, it's annoying because of all those subscripts. So the same idea is going to happen here. We're going to multiply that entire ugly denominator to both sides over 1. It will actually, show up on the left-hand side, and it will cancel on the right-hand side. All right, well, now what I need to do is kind of similar idea, distribute capital F all the way through so I can get the d out of the parentheses, so to speak. All right, now what I need to do is move everything over that doesn't involve d, and that means I'm going to have to subtract over f1 and f2. So let's see what that looks like. I have negative capital FD equals still the little f1 times little f2. Now I have minus capital F times f1 minus capital F times f2. And I'm almost done. I just need to get d by itself. So what I will do is I will divide by negative f. So when I divide by negative f, one thing that's true is we typically don't like a single term to have a negative on the bottom of a fraction. So there is an f on the bottom. But what I'm going to do is that negative, I'm actually going to distribute it through all these terms. And I'm going to rearrange as I go. This is a common thing you'll see as you go further in your math classes, that if you take a negative out and something becomes positive, why not put those positive things up first? So again, because there was a negative down here, and it will multiply to every single thing here, the capital F, F1 will become positive. The capital F, F2 will become positive. And the little f1, little f2 will then become negative. All right, and there we go. And if physics sounds like something you never want to do, maybe you can see why. This is probably some kind of physics formula. You can see how crazy it can be just to deal with all those letters, subscripts, balancing everything out. And that does it for 7.4. Let's dive into 7.5. First thing we get is some word problems, and then something called variations. So let's deal with these word problems. It says, suppose one painter can paint an entire house in 12 hours, and the second painter takes 8 hours to paint a similarly sized house. How long would it take them to paint the house together? Well, here's the trick to setting up this problem. I guess, one, remembering that you're in the chapter that involves rational, aka fractional, expressions. So somehow we're going to have to deal with fractions. But here's how we're going to set this up. We're going to say, in an unknown amount of hours, how do I phrase this? The first painter can paint some portion of a house, but when they paint for 12 hours, the entire house will be completed. So what this fraction represents is when t is 12, well, what would this say? It would say 12 over 12. It would say 1, aka the house is complete once this painter takes 12 hours. Well, the second painter, in the same, time is the same, an hour is an hour for each of them. This painter can paint it in 8 hours. So that's the fraction we set up, because when time is 8, once 8 hours have gone by, the second painter is done. Now, how long would it take them to paint a house together? Here's the trick. If they're working together, they are adding together. And again, the idea is, well, what does it mean to have a full house? Well, it means the entire job is complete, 1 over 1. All right, again, the reason this fraction was set up the way it was is because 12 over 12 makes 1, a finished house. The reason we set up this fraction was because 8 over 8 makes a full house. Well, when they work together, I'm trying to figure out when do they make 1 a full house. Well, we've got some fractions here, and we need to deal with them. And the idea is, let's multiply by the least common denominator. Now, there is no algebra at the bottom, so there are a few different approaches you could take, but let's just stick with the approach we've learned so far, which is, what is the least common thing that 12 and 8 have in common? It's actually 24. So if I multiply 24 to both sides, 24 and 12 will reduce to make 2, and the t will follow. And 8 and 24 will reduce to make 3, and the t will follow. And that'll be equal to 24. So it looks like it will take them 24 over 5 hours, aka 4.8 hours. All right. So both of them working together, this should kind of make sense. Both of them working together should definitely be less than 8 and less than 12. If they're working together, it should be less time than it takes either of them to paint one house. So if for some reason you got something like 9 or 15 or something, then you know you made a mistake, because they should be working faster together than they are individually, unless they're just really not well suited for one another. But we're not worrying about that in math. Okay, up next we've got two different questions that will involve fractions. And these fractions, or these problems, are a little bit tricky. But the thing to remember about both of these two problems is, well, let's just read this first one. A sports car travels 50 miles per hour faster than a loaded truck on the freeway. In the same time that the sports car travels 156 miles, the truck travels 120 miles. Find the speed of each vehicle. The thing that we're going to really focus in on is that speed is equal to the distance you go divided by the time you had to go that distance. So speed equals distance divided by time. Okay, now let's dissect this. It says a sports car travels 15 miles per hour faster than a loaded truck on the freeway. So what does that do for me? What that tells me, the thing is, it says in the same time, so that means that the times are equal. So what I'm going to do is I'm going to take this key formula here, and I'm going to rearrange it so that I can have time be solved for. So let's deal with the sports car and the truck, and we'll plug them into these formulas, and we'll set them equal to each other because the time is what's equal in this problem. Okay, so here's what that means. It says the sports car, the distance it goes is 156 miles. And its speed, I don't know what its speed is, but its speed is 15 miles an hour faster than the truck. Okay, so that time for the sports car is equal to the same time that the truck can go 120 miles with the speed being 15 miles an hour less, aka just its speed without the plus 15. So this is, again, time equals that amount over that amount for the sports car. Time equals that amount over that amount. That's an S. Just kind of looks like a 5. For the truck, right? Again, sports car goes 156, and its speed is 15 miles an hour faster than the truck. The truck is just its speed, no addition necessary, and it went 120 miles. So let's solve these for S. That's what was kind of hanging me up, is that I'm going to solve for S, but I ultimately want to know Well, I guess I do want to know S. That's kind of weird. It's that we never actually find out how much time it's going to take unless we want to plug that in later. So anywho, let's solve this out. We're going to have to take that common denominator approach, so we're going to have to multiply by S times S plus 15 to both sides. And so let's see what that gets us. The S plus 15 will cancel here, so I'll have 156S on the left-hand side. The S's will cancel, so I'll have 120 times S plus 15. And then I'll distribute the 120 through. Whoops. Ooh, 120 times 15 should be 1,800. And then, let's see, that'll be 36S equals 1,800. And that is where I give up and rely on a calculator. So it turns out that the speed of each vehicle, well, the speed of the truck is 50, and the speed of the, so maybe I'll put truck, and the speed of the car is going to be, well, 65. 15 miles an hour faster. And what you can do, just to double check, is you can check, well, what is 156 divided by 65? I get 2.4. And what is 120 divided by 50? I get 2.4, aka that the time is equal. The time gives me 2.4 hours and 2.4 hours. All right. So the key there is that speed is distance over time formula and manipulating it and then setting them equal to each other so that our times are equal. Let's see how the second problem goes. Garth can row 5 miles per hour in still water. It takes him as long to row 4 miles upstream as 16 miles downstream. How fast is the current? So something tells me this is another distance over time problem. And so we know that Garth's speed is just, well, 5. And this is also going to be another one that says it takes him as long to go 4 miles up as 16 miles down. So this is another case where even though speed is distance over time, we're going to rearrange that to be distance over speed. So his still speed of 5 miles per hour. Wow, I see. So we can row 4 miles upstream. So that's when his speed is being added to, when his speed is 5, is being added to the speed of the current. And that same amount of time he'll go, subtracted from the current because he's going upstream, he's going against the current, so they're subtracting from one another. He can go 16 miles an hour when his 5 speed is added to the speed of the current because now he's going along with the current. So there's that whole addition subtraction of the current with or against. We saw the same thing with the airplane problems. Okay, well, let's solve these. Again, what I'm going to have to do, and this seems kind of silly because it seems like they're so close to being the same, but I still need to multiply everything by 5 plus c, 5 minus c, both denominators. And one will cancel and one will be left over. Okay, so in this case on the left-hand side, the 5 minus c's cancel. So I've got a 5 plus c distributing to 4. On the other side, the 5 plus c's cancel, and so I've got a 16 distributing to a 5 minus c. And that's going to be 20 plus 4c equals 80 minus 16c. That's going to get me 20c equals 100. And so c will equal 5. No, because that will subtract and make 60. And so the current is 3 miles an hour. There we go. All right, there we go. Sorry, I don't know what happened. That section threw me for a loop as well. So the key takeaway that took me a while to wrap my head around was, be careful of reading. Are you going with or against? Are you adding or subtracting? Speed plus 15, where does that plus 15 go? Make sure you get it on the right vehicle, otherwise things are going to be incorrect. And then secondly, remember that speed is ultimately distance over time, and you might have to rearrange that formula to apply it to the verbiage of your problem. Okay,